Okay, so we have this interesting exponential equation here. We have 4 raised by x minus 25 raised by x equals 10 raised by x. Okay, so let's go right into it. So we will rewrite them. For example, 4 raised by x can be written as 2 times 2 all raised by x minus 25 can be written as 5 times 5 all raised by x. Then, of course, 10 raised by x can be written as 2 times 5 all raised by x. So we'll now open the bracket. And how do you open this bracket? I will use the power outside the bracket to multiply the powers in the bracket. Of course, this 2 has a power 1 and this other one has a power 1. So write out your 2 first and you do x times 1x times, write out your second 2 and do x times 1x. Then minus, do the same thing here. Use the power outside the brackets to multiply the powers in the brackets to open the bracket. 5 has a power 1 and this other 5 has a power 1. So you have, write your 5 out first of all. Then x times 1 is x times, write the second 5 down. Then x times 1 is x. Then equals, do the same thing here too. This 2 has a power 1 and 5 has a power 1. Use the power outside the bracket to multiply the powers in the bracket. So you write your 2, then x times 1 is x, times, write your 5, then x times 1 is x. Okay, so now the next thing is we could divide through by this value, 2 raised by x, 5 raised by x. So let's divide through by this value. So 2 raised by x dot 5 raised by x, everywhere by it. Also divide here by 2 raised by x, 5 raised by x, and here also 2 raised by x, 5 raised by x. So this cancels out. I have 2 raised by x over 5 raised by x minus this, and this cancels out. I have 5 raised by x over 2 raised by x remaining equals, this cancels this, we have 1 remaining. So I have 1. But this value and this value are not the same. So I can make them look the same by manipulating this again. So if you want to manipulate this, we can follow this rule here. Because this is 2 raised by x over 5 raised by x, and this is 5 raised by x over 2 raised by x. For this to look like this, it has to be 2 raised by x over 5 raised by x. So I'm going to follow this law here. So if you have a over b all to the power of x, it can also be the same thing as 1 over b over a all to the power of x. Notice that the a and the b have swapped positions here. So that's what I'm going to do here. So following this law for this one, and I have 2 raised by x over 5 raised by x minus 1 over, this one's swap over 2 raised by x over 5 raised by x. So these swap positions. So of course 2 raised by x over 5 raised by x, same thing as 2 over 5 all raised by x minus, this one is the same thing, 1 over 2 over 5 all raised to the power x. So notice what I did here. This whole swapping here was from this law here, this over this, all power x can be 1 over, or it can, even if you even open the brackets, a raised by x over b raised by x, same thing as 1 over a raised by x, b raised by x rather over a raised by x. This is exactly what I did here, so don't get confused. So from this it became this 1 over swapping of this. So finally this and this are now, they're now the same. So continue your equation, equals 1. So then since they are the same now, I can say let 2 over 5 raised by x be p. Yes, I can do it that way. So I now have let 2 over 5 all raised by x be p. So we can now rewrite the equation. Since these values are now p, I can now say this one is now p minus 1 over p equals 1. So I'm writing that p minus 1 over p equals 1. Then multiplying through by p to eliminate the denominator, times p times p times p. This becomes p squared minus this cancels this, you have 1 equals 1 times p. Then rearranging, you have p squared minus p minus 1 equals 0. This is a quadratic equation and we can solve using the quadratic formula. So using the quadratic formula, I have p equals minus b plus or minus root b squared minus 4ac everything over 2a. So of course my a is 1, coefficient of p squared, and my b is also 1, coefficient of p, and my c is minus 1, the constant. So I'll just fill them in. So p equals minus, well, let me just write it out. A equals 1, b equals minus 1, and c equals minus 1 also. So let me just fill them in. So b is minus 1 plus or minus root, again that's minus 1 squared minus 4, let me put this one in bracket, 4 times 1 times minus 1, close the bracket, everything over 2 times 1, still 2. Then I have p equals minus times minus is plus, plus or minus root, this is 1, then 4 times 1 times minus 4 is minus 4, everything over 2, then we'll get p equals to 1 plus or minus root 1 minus minus 4, that's minus and minus is plus, then that 4 plus 1 you get 5, everything over 2. So these are our values, but it doesn't end there, so we can have it this way. So from here we now have p equals either 1 plus root 5, 1 plus root 5 over 2, or p equals, using negative sign now, 1 minus root 5 over 2. But remember that we made p was equal to something at the initial stage. We said let 2 over 5 raised by x be p, so I'm bringing it back to the equation. So we have it this way. So p equal, this one is now 2 over 5 raised by x. 2 over 5 raised by x equals 1 plus root 5 over 2. Then I can log both sides. So I now have log, I can log both sides to make my work easy. 2 over 5 raised by x equals to log, of course I'm using log to the base 10, log 1 plus root 5 over 2. Then of course I can transfer the power of the number here over to this side to be in product with this logarithmic expression here. So now I have x log 2 over 5 equals to log 1 plus root 5 over 2, and then of course I'll divide both sides by log 2 over 5 so that the x will be isolated. Divide here by log 2 over 5. This cancels this, and my x is now equal to log 1 plus root 5 over 2 all over log 2 over 5. This is the exact value of x. Then if you now impute this or put this into your calculator, use your calculator to evaluate this, you get x is approximately equal to minus 0.5252. This is what you get as an approximate value of x, but this is the exact value of x. So now coming to this other equation here, the same thing, I'll rewrite this as 2 over 5 all power x, which is equal to p is equal to 1 minus root 5 over 2. Then logging both sides, log of 2 over 5 raised by x equals to log of 1 minus root 5 over 2. Then transferring the power to this side to be in product with the expression here, you now have x times log 2 over 5 equals log 1 minus root 5 over 2. Then dividing both sides by the log 2 over 5. So divide here by the log 2 over 5, and here by log 2 over 5. This cancels this. My x is now isolated. It's now equal to this exact value, 1 minus root 5 over 2 over log 2 over 5. Then if you now again impute this into your calculator, you see you now get x is approximately equal to, this will give you an imaginary value. It's going to give you 0.5252 plus 34286, 3.4286i. So that's it. This is the exact value and this is your approximate value of x. So that's just it.